Assalamualaikum warahmatullahi wabarakatuh. My name is Saris Nunaza binti Zuhirizan and my metric number is CE190061. I am from Group C and then I have 4 members in Group 6, Muhammad Safi, Nurul Shuhana, Nurul Shamimi, Wan Muhammad and Zarismi. And today I want to explain the introduction of experiment to computation of blind parameters. So this is the introduction. The aim of this experiment is to determine the positive sequence line parameters L and C per phase per kilometer of a three-phase single and double circuit transmission lines for different conductor arrangements and to understand modeling and performance of medium lines. The performance of a transmission line is determined by its parameters. There are 4 electrical parameters in a transmission line: resistance, inductance, capacitance, and conductance. The effect of magnetic fields around the conductor cause inductance and capacitance. The parameter R, L, and C, resistance, capacitance, and inductance, are required for the development of a transmission line model that will be used in power system analysis during both the planning and operation stage. While the conductor's resistance is best determined using manufacturer data, inductance and capacitance can be calculated using the appropriate formula. Transmission lines are long-distance cables that carry electrical signals with minimal distortion and energy loss. One of the most essential electrical parameter is resistance, which is defined as a material feature that limits the flow of current in a circuit and so protects the circuit elements. The SI unit for resistance is ohms. Conductance is the reciprocal of resistance, which is the quality of material that permits current to flow through it. The SI unit for conductance is mho or Siemens. Capacitance refers to the ability of two conducting plates to store electrical charges. The capacitance between the conductors is determined by the size, spacing, and height of the conductors above the ground. Farads is the SI unit for capacitance. A current carrying conductor generates a magnetic field all around the conductor. When the current varies, the flux changes, causing a voltage to be generated in the circuit. Flux linkage per ampere is the definition of inductance. Henry is its SI unit.
Assalamualaikum. My name is Nurul Shamimi binti Abdul Aziz, CE190184. Today I would like to explain about the exercise 1 in the uji kaji 2. Okay, this is the question given. A 500 kV 3-phase transpose line is composed of one ACSR 127200 Siemens 45/7 meter conductor per phase with horizontal conductor configuration as shown in figure 1. The conductor has a diameter of 1.345 inch and GMR is 0.5328 inch. Find the inductance and capacitance per phase per kilometer of the line and justify the result using Matlab. Okay, this is a figure 1. They also give the distance value between AB, BC and AC. For the AB is 35 and BC also 35. And the total of AC is 70. Okay, before we find the inductance value and capacitance value using Matlab, we need to do the manual calculation first. Okay, this is the manual calculation. The formula for find the inductance per phase is provided on the lab sheet. We can just go and use it. Okay, the formula is L equals 0.2 ln GMD over GMRL. Okay, before that we need to find GMD and GMRL first before we find the inductance per phase value. Okay, for the GMD, they also provide the formula. The formula is cube root AB times BC times AC. This is the distance in the figure 1. We just put the value on the cube root 35 times 70, and the answer is the answer is 44.097 feet. Okay, for the GMRL, they also give the value, but we need to convert inch into feet, so we need to divide by 12. So the value give is 0.5328 over 12 equal 0.044 feet. Okay, after we get the value of GMD and GMRL, we need to put on the formula and we can get the answer for inductance per phase. The value of inductance per phase is 1.38 millihenry per kilometer. Okay, after that, we need to find the value of capacitance per phase. They also give the formula. The formula of capacitance is 0.056 over ln GMD over GMRC. Okay, in this formula, we just need to find GMRC. For find the GMRC is equal to R, but we need to convert inch to feet. So to find the GMRC, we use the formula divide by 2 and times 12. The R is given, so we just put the R. R is 1.345 inch divided by 2 and times 12, and the answer is 0.056. This is the answer for GMRC. So we put the value GMRC, GMD, and we can get the answer for the capacitance per phase is 0.0083 microfarads per kilometer. Okay, this is a value that we can get from the manual calculation, and we can do by using Matlab. Okay, this is the coding that provide on the lab sheet. We just copy and paste and just run to get the value of inductance and capacitance. Before that, we need to enter a few value in this coding to get the answer of L and C. So this is enter AB. AB is 35, BC is 35 also, and AC is 70. Okay, enter the GMRL. Okay, the GMRL is 0.0444. Okay, we get the answer. The answer for inductance per phase is 1.3802. It's same with the manual calculations. And we need to find the capacitance per phase. Is it same or not? Okay, the inductance diameter is 1.345. Enter. Okay, this is the value of capacitance per phase, 0.0083 in microfarads per kilometer. For the inductance also in millihenry per kilometer. This is the answer, and this is the analysis for the coding that we have done. Okay, that's all for me. Thank you.
My name is Nurishwana binti Azhar, CE18174. In this video, I'm going to explain regarding exercise 2, which is basically this exercise 2 asking us to find the value of inductance and capacitance per phase per kilometer with the data given here, which is conductor diameter of 0.977 inch and also the value of GMR of 0.3924 inch, and also bundle spacing is 18 inch. As we know, the formula to find the inductor per phase is 0.2 inch GMD over GMRL. While to find the capacitance per phase, the formula is C equal to 2 pi E0 equal to inch GMD over GMRC. So, we need to find the value of GMD, GMRL, and also GMRC in order for us to use this formula to find capacitance and also inductance. So we can find the GMD by multiple the value of AB and BC and also CA power of 1 over 3, and then we get the answer is 44.097. We also need to find the value of radius, which is we need to divide the diameter of conductor value with 2. So we divide 0.977 inch with 2, then we get the answer is 0.4885. And we need to find the value of GMRL. GMRL formula is square root D multiplied by DS over 12. So D is the value of bundle spacing here, which is 18, multiplied by DS. DS is 0.3924 inch over 12, and then we get the answer 0.22147. And then to find the GMRC, the formula is square root D multiplied by R over 12. D is spacing and R is the radius that we already found just now, which is 0.4885 over 12. And then we calculate, we get 0.2471. After we already find the value of GMD, GMRL, GMRC, we can use this value to find the inductance and capacitance. So without further ado, we just put the value we have here to this formula. So inductance formula is 0.2 inch GMD over GMRL. So the value of GMD we get 44.097. Here we put, and then the GMRL value. So the value of inductance we get from this formula is the 1.0588 millihenry over kilometer. So for the capacitor formula is 2 pi E0. This is the fixed value, which is 0.0556 over GMD 44.09 over GMRC. So GMRC is 0.2471 So we calculate, we get 0.0107 microfarad. So here is the manual calculation to find inductance and capacitance. So let me prove our manual calculation using the Matlab software. So here is the program that I already ran just now. So this program taken from the lab sheet given by the lecturer. So let me see each of the commands. So DAB is the distance of A to B. So we already put here DAB value is 35, and DBC is the command for the value of distance B to C, and also DCA the value of distance of A to C, which is 70. We put here 70. And also this is the formula of GMD that I already explained just now. The formula of GMD is multiple of AB distance, BC distance, and also AC distance, power of 1/3. Here is the formula. So this is for diameter conductor. This is the formula of radian. This is the bundle spacing input, and this is the GMR, and here is our formula that we use to find the GMRL just now in our manual calculation. This one is GMRC, and then this command is for display our result, which is our inductance result. This is the formula of inductance. So this is the command to display our answer, and here is command to display our capacitor value, and we just need to put the capacitance formula here. So after we run our program, this command window will asking us to enter each of the value that we already write in this command. So after we insert all the data, then we will get the answer. Inductor is 1.0588 and the capacitor is 0.0107 in microfarad per kilometer, which is this answer is equal to our manual calculation here. So here is the workspace that our data will be saved in our workspace. So that's all from me for exercise.
Assalamualaikum warahmatullahi wabarakatuh. and a very good day. My name is Muhammad Safi'i bin Muhammad Saleh. My student identification number is DE190048. Okay, so today I will be presenting a video for Lab 2 for activity or exercise number 3. Okay, first we check out the question. Okay, here is question for this lab work or for exercise 3. So I will be presenting the simulation for this question. Okay. Okay, so here I have written the program script here, which I have written as program 3 here. Okay, so I will be run it. Okay, so when I run, the command window will pop up like this. So often I will drag this to the upside. So here it shows that I have to enter the row vector for S11, S22 and S33. Okay, so I will be entering the value. The first value for S11 is S11 is 11, and for S22 is 16.5, and for S33 is 12.5. Sorry. So we'll press enter here, and then it shows that I have to enter the row vector for H12 and H23. So the value for H12 is 7, and the value for row vector H23 is 6.5. Then I will press enter here, and then it asks me the bundle spacing in inches. So the bundle spacing in inches is 18. Then I will press enter, and then it asks me a conductor diameter in inch. So the diameter is 1.42427. Then I will enter, and then it asks me the geometric mean radius in inches. So the value is 0.564. Then I will press enter. So from the program, we will calculate the GMD, GMRL, GMRC, and LNC. So all the formula have written in the report, which later will be viewed and assessed. So from the program and all the parameter that I have put in this comma window, so the answer for GMD value is 12.0323, and for GMRL value is 1.0312, and for GMRC value is 1.0937. So for my L value or inductance value is 0.4914, and for my C value or capacitance value is 0.0232. Okay, so that is all the simulation for this exercise 3. So that is all from me. Thank you.
Okay, Assalamualaikum. My name is Wan Muhammad Azam bin Wan Harun, and today I want to present about discussion. We learn about the concept of GMR and GMD from the lab experiment. GMD is for meaning geometrical mean distance, is an abbreviation for geometrical means distance. It's a distance between conductors that equivalent what when there are two or more conductors per phase, such as in bundle conductors. GMD comes into play. Geometric means radius. GMR is an abbreviation for geometric means radius. GMR value are determined by the size and configuration of the conductors. GMR is the conductor's effective radius as a result of the internal flux leakage. The GMR is equal to the radius of the conductor if there is no internal flux connection. For alternative conductors arrangement, we can also find the value of uh, positive sequence line parameters L and C per phase per kilometer of the three-phase single and double circuit transmission line. Before we could get the value of inductance and capacitance, we need to get the value for GMD and GMR. Using the provided programs coding, we were able to calculate the values of GMD, GMRL and GMRC by entering the input value for DAB, DBA, DCA and conductor diameter. We obtain the values of L and C as a result. The experiment had some challenge because we encountered an error while running the program, but we overcome the problem and outcome was satisfactory. That's all from me.
This is
Thank you.
the conclusion that we get from all other results from the experiment too. In this experiment, students have to determine the positive sequence line parameter, capacitance inductance, capacity inductance per phase per kilometer of a three-phase single and double circuit transmission lines for different conductor arrangements and to understand modeling and performance of medium lines. Outcome from this experiment, we can conclude that the positive line parameters L and C were determined and checked with Matlab. Profile per phase per kilometer of three-phase single and double circuit transmission lines for various conductor arrangements. The simulation was carried out for several single-phase and three-phase line situations. As a result of the conclusions, the outcomes are compared by the example of the number of drivers in each scenario varies from 2 to 4. The number of conductors increased and the capacity of both single and three-phase line decreased. Thank you.